continue with the last lecture's example, and then we talk a few more examples, and then we introduce a new topic, debugging. So today's lecture full of examples. So the first example, in last lecture, we mainly talk about loops, for loop and while loop, and you're gonna understand the difference between for and while loop. So if you know the exact iteration number, you're going to use for loop. So otherwise, if you only know the condition, you use while loop. So here is our last example about bridge resonance. So I give you 1 minute to have a look of this example. Okay, all right. So this is an example about bridge resonance. So for example, if in engineering, if you design a bridge, okay, for example, you design a bridge, so what you're going to do is you put pillars. So this is to anti the wind resonance. So normally, when you place pillars, it's going to be a pair at the top, at the bottom, okay? So this is, for example, this is a bridge. You place many pillar pairs. And then you're going to check what's the frequency of these two. And compare these two frequency with wind frequency. And check the frequency difference and make sure that both pillar frequency compare with wind frequency. The wind frequency have three different frequency: 0.28, 13, 0.08. You compare this frequency with these three frequency and make sure any pillar pair, their frequency difference from the wind frequency must be beyond this safe region. If it's within this safe region, then this pair that you design has some problem. That clear? So now we have how many pairs? 1, 2, 3, 4, 5, 6, 7. So we have 7 pillar pairs. So what you're going to do here is, for example, let's check the first pair. Okay, this first pair frequency is 0.24, 0.2. So what you're going to do is you check this frequency first, 0.24, and then you compare with the wind frequency. So you compare the difference. The 0.24, 0.28 compare the difference, 0.04. Okay, 0.24 compared with 0.13. What's the difference? 0.09. Okay? And the last digit, 0.24 with the last one is 0.16. Okay? The difference. So these three difference all above this safe margin. So it's fine. And then you check the other pillar in this pair, 0.20 compared with 0.28. So the difference is going to be 0.08. And similar, repeat with 0.13, 0.07, and the last one is 0.12. So they are both fine because the frequency difference is beyond this margin. Okay? So this is the idea. So this idea we're going to use two for loop. Okay? So in this example, let's see this example. So first, you assign all this frequency of pillar pair to this variable, bridge frequency. Okay? And then you assign this wind frequency, this 3, to this variable, wind frequency. And the safe margin is 0.03. And then you say the size of this random, this variable, bridge frequency. So when this size is a built-in function in MATLAB. Okay? So this size give you the row and the column number. For example, we say A is 1, 2, 3, 2, 3, 4. This A is a 2 times 3 matrix. If you say size of A, it gives you 2 numbers. Okay? The first is row number, the number of row, the number of column. But if you say size A, you specify 2 is the second value. So it only give you the column. Okay? So that's why if you specify 2, this means how many column you have? 7 column. This will give to number of pillar pairs. And then you pre-allocate a variable called result. So this number of pillar pairs is 7. So you make a vector full of 1. You have 7, 1 here. This is called result. So you pre-allocate this result. And then following, you use two for loop. The first is to check the number of pillar pair. This is just 7, okay? And the second is to compare wind frequency, the length, which is 3 here, okay? So W is the wind frequency, P is the frequency of pillar pair. So you just do an exhaustive search, okay? You do an exhaustive comparison. So then that P at the beginning is 1, okay? So the bridge frequency here, the first row, first column is this one, compared with the wind frequency. Wind frequency at the beginning is 1. And then this compare with this one, okay? And then the second row, the first column, this one, compare with wind frequency, first one. And if they are all within this margin, both of them within this margin, actually, they both are not within this margin, okay? So this is not satisfied. Then you go on. So next loop, so what you change is here, okay? Because it's inner loop. So that means it's still 0.24, 0.3. You're going to compare with 0.13, the second value. And then you do a comparison. And then the third loop is the W changed to 3. So that means you compare with the third wind frequency. You do this exhaustive comparison until you hit a pillar pair that the frequency is really within this margin. Then you can update. Imagine if there is some pillar pair, for example, this one, is within the margin. Then the result of that point gonna be updated to 0. Okay? So according to what you have here, this matrix, and then we call function to print out the whole thing. This function you don't need to know because this function is a bit complicated. So here is the MATLAB function. So here is a MATLAB code that exactly is like what I explained. So let's run this. So here is the output using that call that function. So you can print out this pillar pair along the bridge. So X indicate a bad pillar pair. So it's the third one. So if you go to the third column, it's 0.29, 0.3. Because 0.29, first you compare with the 0.28. It is 0.01. It's within the safe region, the safe margin, okay? And how about 0.3? Compare with 0.28 is 0.02, the difference. So it's all within the safe margin. If within the safe margin, safety margin is not good. We want beyond that margin. So, so what we can change here, when you design this frequency, you can just increase this frequency, and then it's going to work. Okay, you see, this bad part was removed. So this example is just to make you to be familiar with this for loop when you nest two for loops together. And this is the last example from the loops. So now we're going to move to another example. This example is also, we're going to use loops. So it's Markov chain. Have you studied Markov chain? Yeah, okay. So Markov chain in this example is very easy. It's application of a factory, and you know what you have now, and you also know previously what's going on. So you want to estimate for future. So Markov chain is like that. It's normally Markov chain model can be used in engineering or even the stock market, because after long-term observation from, for example, past few weeks, you estimate the stock, for example, the stock market for the current week. Okay, so this is the idea of Markov chain in this example. So in this example is talking about a factory is making widgets. So the widgets, it didn't specify which kind of widgets. It can be a car factory, it can be an airplane factory, and can be some other factory. So anyway, you produce some widgets, and the problem is ask you, now imagine you are a manager there, and you observe this factory, and currently this is how much you produced. Okay, you produce this amount of widgets at this week, K week, and this is how much inventory in the current week, K, and this is how much you sold in this week, K, about widgets. Okay, so you use how much you produced, how much you have in storage, and minus how much you sold. So this outcome will be used to estimate the next week's inventory. Okay, so this is the example of, this is mathematical expression of our example of Markov chain model for this widgets manufacturing. And giving this, now we have the example. Okay, so now our example is to saying the widgets manufacturing is from first week to the week 10. We have sold all this number of widgets, and ask you to predict the week 11, how many widgets still in inventory. Okay, so based on this model, and based on this model, we have how every week sales rate. So it's here. So this is okay. We have it. It's given in this table. And how many inventory normally we have? This we don't know, right? Because you're going to estimate every time, every week. Okay, so how many we produced? There is an assumption. So this produce rate, we assume we produce enough to cover last week's sale. So this PK is just last week's sales rate. Okay, so you have this, then you can calculate this inventory rate. But for initialization, you need a value at the first week. So we just give 50 because it's first week. Okay, sales rate is 50, and this produce rate is also 50. and the inventory rate is 50. Give some initialization to start with. So it's very easy. You just plug in this model and do this computation and write the MATLAB codes. But as usual, step 1 is pseudocode. So this pseudocode means you list the step, what you're going to do here. First, declare a variable and calculate production, the rate, and then calculate the inventory using this Markov chain model, and then you plot. So this is what you're going to do. As a pseudocode, you copy-paste to the MATLAB M file, and then just fill in each step. So weekly sales, you just define as a vector and give to random variable s. So the number of weeks is 10, in fact. So you give to assign to number of weeks. So then this is the production rate. This is inventory rate. This P and I, we need to do a pre-allocation. So pre-allocation I'm going to talk about next week. Pre-allocation is speed up your MATLAB computation. So normally, to deal with matrices and vector, we do a pre-allocation. So pre-allocating P, we say all zeros. The size and number of weeks, okay, is a vector. The inventory is going to be number of weeks plus 1, the size. Why? Because you always use the current thing to estimate the next week. Imagine totally you have 10 weeks sales and production rate. You're going to estimate the week 11 inventory. So that's why the dimension is number of weeks plus 1. And then you calculate. Then what you're going to do is you calculate the weekly production. So weekly production, you need initialization. Initialization is 50, and then the K is from week 2 to number of weeks. For the week 2 production rate is going to be the previous week's sales rate. Sales rate is given here. Okay, so and then after given production rate, and then we calculate inventory. Inventory, the initialization is 50, and then you use a for loop to calculate, using this Markov model to calculate this inventory rate. So this is pretty much about this example, and then here is the outcome. So let me show you. Here's the widgets, okay? And basically, this is what you computed. So the blue and the red curve is, the blue one is the legend is given here, is production. Okay? The red curve is the sales. So sales and production pretty much is well aligned with each other. And the inventory is the black curve. Okay? So this is the a small example. So the main purpose is to let you get familiar with the for loop. Okay? So these two examples is all about for loop. And also, you can write a function instead of for loop. This is very easy, right? So this is basically what you're going to do is you put this whole box here as a function. You call widgets. Okay? So this is exactly the same as the previous MATLAB codes. You just add a function declaration, say function, and call it, the function name is widget function. And this is what you compute. So what you compute is production and inventory. Okay? So you have two return variables, I and P. And how about input? Input is going to be the sales rate. Okay? So it's the vector is given here. Okay? This is your input. This is your input, and this is your input. So you have input and the initialization of P0. P0 is just 50, and I0 is 50. Okay? The initialization of produce rate. Okay? And then you can make this function, you call this function. This is a two-way of building this MATLAB code. It's all working, okay? So that is two small example for us to practice to do for loop. Now we talk about another topic, is debugging. So debugging is normally you have a long MATLAB code and you want to find where is the mistake, and you do line by line debugging. So instead of following these slides, I will just show you how we're going to debug. But before the debugging, I want to show you an example. So using this example, I'm going to show you how to debug. So this is first example. The main code is here. So give me your vector V. Is from 1, 2, 3, 4, 10. Okay? And these three, the two functions and this main code is asking you to calculate the average of this vector and to find how many elements of this vector is greater than the average. For example, V is, okay, so the average V is just 4. And then you're going to write a MATLAB code and check how many elements is greater than 4 in this V. Is 1, right? Okay, so this is a 2 function, is calculating that. And let's see this. So then what we get, the number of elements is above the average is 3. So something wrong with this MATLAB code. Okay? And let's check where is wrong. So let's do a debugging line by line. So how do we do it? So for example, you decide, let's start from at the beginning. So you just click. There's a column here. You click here. So this will create a breakpoint. The breakpoint means when you run this MATLAB file, okay, so it will break here. It will stop here and wait for you to debug. So you can see a green arrow is pointing out this line. That means your debugging going to start from here. And also this command window, you have this very odd sign here. That means the mode is debugging mode. Okay? And then you click here, debug. Okay? So you can either put step or step in, or equivalently you press F10 or F11. So F10, F11 all means line by line debugging. The only difference of F11 and F10, F11 step in means if you have a function, you can go in the function. So here we have a function, we do have a function. That's why we use F11. So when you use F11, you can see it's line by line debugging. When you debug, you can observe here the workspace. Now you observe the V was created here. It's 1, 2, 3, 4, 10. So it's fine. And then you press F11 to go in function 1. So now we go in function 1. So function 1, the first line, AVG is calculating the average. Okay? Press F11. So you see the average is 4. Is exactly what we computed before. So the average is correct. And then you press F11 again to go on to another function called function 2. So this is function 2. And this is obviously to test this vector x greater than the average and find how many elements in x should be greater than that average. So now, surprisingly, when you go in this function, the average changed. the average changed to 1, 2, 3, 4, 10. What we computed before the average was 4, and now y average changed to a vector. So what's wrong? It must be something wrong with this code. Okay? So can you tell me where is wrong? Where's the mistake? So here it was still calculate all right. Okay? It was still 4, function 2. And then when you go to this function, it becomes something wrong. So what, can you tell me where's the mistake? Yeah? Exactly. Thank you. So these two variables, the sequence swapped. So you should be AVGX. Sorry. Okay, let's, anyway, first finish this. So when you're going to finish, this green arrow is facing down. That means you're going to end the debugging and F11, and you exit. Okay, let's go here and save it. So we correct this bug, and then now it's correct. So any question about this MATLAB function, or you didn't follow where the mistake is? Any comments, any question? Okay, all right. So any question, or if you feel confused, you can stop me and ask. Okay. So this is the first example. So in this today's lecture, I'm going to show you 3 examples, all bugged, all have mistake. So I hope you can tell me where is the bug. Okay. So the second example is to say, for example, this is a main function. Mean code. Okay. So this main code is saying, for example, 2010. This is what you put in Commonwealth Bank. This $1,000. This next year you placed $1,500 to Commonwealth Bank to save it. And this is the 3rd year you place how many money in the bank. And this MATLAB code is to ask you, after these 3 years, what's the total money you get? The interest rate is 10%. Okay, every year is 10%. It's very high interest rate. Okay. So you call this function invest to compute. So let's first do a computation. So 1,000, you first put it in. And the rate is 10%. So what do you get here? You get $100. So 100 plus 1,000. After 1 year, you get 1100. Okay? And then the second year, you placed 1500 together. So you have 2600. Okay? And then this is second year total amount of money you get. And then you how much interest you have? 260. So then you have 2,600 plus 260. You have 2,860. This is year 1 you get, and then this year 2 at the end you get. And you repeat this progress for the 3rd year. So totally, I estimate you at least get kind of 5,000, around 5,000 something. Okay. So let's see. This is the second MATLAB code. Let's see how much money you get. Oh, you only get 1,000. It's absolutely wrong, MATLAB code. Okay? So let's make a debugging. So we still start from beginning. You make a breakpoint here, and you run and press F11. So when you press F11, you check the workspace. X is all right. R is all right. And then you go to this function called invest. So Z is initialized to be 0. Y is the interest rate is 0.01 plus 1. It's going to be 1.1. So everything what you input times 1.1. This is all right. And then you compute iteratively the total amount after 3 years. Okay, K is the index for year. So then you check K equals 1 is for first year is still all right. And then this is what you get. And then you F11 again. And then it's not repeating. Okay, it's only calculate first year and it's going to leave because here the green arrow is facing down means it's going to end this for loop. So there is something wrong here. Can you tell me where is the mistake? I can tell you it's here. The for loop starting point has some mistake. So where is the mistake? X. The number of iterations from 1 to length of y. From 1 to length of y. What? So y is the interest rate. You want the length of the year. So here should be x, right? Right? Is any question? All right? So we press F11 and exit. So here's the problem. It was y. Y is the interest rate. Okay? So you should put length of x the year. So here is like the final total amount. So this is the debugging example, second debugging example. So now the third example. The third example is going to be an infinite loop. So now I give you 1 minute, and you have a look and tell me where is the problem. So imagine debris.txt, the file is like 1, 2, 3, and second line is 2, 3, 4. It's 2 lines of text file. So, so our target is to open that file and read these 2 lines. So this MATLAB code didn't really do this operation. So can you tell me why? Anyone spot any part which is suspicious? FGetL is get a line at the time. No, if you use string to number, it did get back to the variable. It did get to all these 1, 2, 3. So where's the mistake? A -1, that means this is a special thing from FGetL. FGetL, if you return -1, means it reached the end of the file. So it's not -1 at that point. So, but it's something related to this while loop, something here. So what is this while loop is going to be an infinite loop. So why? It's an infinite loop. So I can explain that FGetL is to read a line. So first, let's say you have a file name. You use fopen to open this file. and the mode is R, is reading from the file. Okay? Once you're reading from the file, you use fgetL. fgetL is go inside the file and read a line. So at the beginning, it's going to be read the first line, 1, 2, 3. Okay? You read the first line, assign str. But it reads the first line as a string. Okay? So assign str. And inside this loop, you use string to number to get back 1, 2, 3 as a number and assign to data. Okay? But what is str? str is still a string. Okay? And then you use this while loop to compare. Is this string not equal to -1? Yes, it's not equal to -1. The string will not equal to -1. Okay? And then you use string to number to convert the string to number and assign to data. But you never really updated this str, right? You didn't keep reading. So this str was never updated, right? So then you will end as a dead loop, infinite loop, that you keep convert this str to number and assign to data. But in fact, you never updated str. So how do I change this MATLAB code? Because you only read the first line, okay? And then inside the while loop, you keep changing the string to number, assigned to data, but you really never updated str. So you can add a MATLAB line here. After this assignment, you add str fgetL fid. Okay? So you add one more line to let it read the next line. Okay? So if it's read next line and then you change, after reading next line, and then you use while loop to convert them to number and assign to data. So here are also some mistakes. So this data, if you want really to place as a vector, so you should change this data to a vector. That n, this means all column, and assign string to numbers str to this data. And after this line, n is updating. Okay? At the beginning, you should put n is, for example, 1 to start with. Is that clear? Any question, any point? Any question? Understand? Okay? So feel free to ask. So this is, will not end the dead loop. Let me, so let me show you the last example. So for example, if I didn't really put this, keep reading this line, what we're going to do here is going to be an infinite loop. And you can see here it shows busy. So let's break it and add this line. And here is what you get. This is all data. Okay? So this is our last example. So any question that you feel confused, you can feel free to ask. So this is pretty much for today. And next week, we're going to have the last week on lecture part A. So I will see you next week. Have a great